All right, hi everyone. My name is Anthony, and I'm your TA for MGG 633 Data Modeling. I'm recording this video because our audio did not work on Tuesday night. So if you are wondering why there was no video, that is the reason. Hopefully we get that resolved shortly. But I'm going to go through the 3 problems that we solved on Tuesday. And if you have any questions, you can always reach out to me via email. It's on your syllabus and on UB Learns, where you can reach that email. So we are going to go quickly through how to set up your eAssign, and we'll go through 3 different problems on your homework assignment that is due Sunday night. All right, I'm going to share the screen. Okay. So the first thing that you are going to have to do is set up your eAssign account. And you can do this by going to eassign.com, hitting login or register. Once you've registered, you'll have to enter a course code, and you can find that code on UB Learns. And you'll notice that all of your homework assignments are listed. For homework number 1, click on that, and you'll find a files for homework number 1. Click the link, and it will start to download. Give your download a couple minutes after signing up for your eAssign account so that the website can catch up. If you're having issues downloading, let me know. You can shoot me a quick email, and we can see if we can get that solved for you. We were having some issues on Tuesday night, and we think that that is because the website takes 5 to 10 minutes to update and create the file for you before you can actually download it. So your homework assignment is based on if statements, and when you open it, it will look just like this with your academic integrity page. The way eAssign works is it tracks where your Excel document has been, so it will know if you have shared your document with someone else. This is a bigger issue for undergraduates, but I thought that I would let y'all know that if you share your document between team members, this website will pick it up and report it for academic integrity. So make sure that that's not happening. You'll see a bunch of different tabs, and these tabs correspond with your homework assignment, which can be found in UB Learns. If you log on to UB Learns, click on MGG 633, go to Assignments and Individual, and you'll find the document that lists all of your individual assignments for data modeling. If you scroll down to individual assignment number 1, if statements, you'll find a description for each different tab. Tickets, drug, bid, date, CRAPS 1, CRAPS 2, a candy model, and a break even, and last but not least, a make a chart. One thing to note, the CRAPS 2 assignment, number 6, this is for advanced Excel users. So give it a shot. If you feel comfortable with Excel, try and solve it. The way Frank designs his homework assignments is that these advanced Excel user problems are worth fewer points. It's great extra practice for some of the better, more skilled Excel users. But if you don't feel comfortable doing it, take a look at it, decide how you might solve it, and go from there. If you can't solve it, it's no big issue. So let's get back into the first assignment. We'll start on the Tickets tab. So the Tickets tab is talking about a fly-by-night airline that is selling airplane tickets to 270 people, but they only have 250 seats. Assuming that certain people don't show up for their flight, we want to calculate how much the overbook cost would be. So you'll notice that in columns B through H, the number of tickets sold remains the same. The number of seats available also remains the same, but the number of people that show up for the flight differs by 5. You'll also note that the unit cost and the overbook fee are all the same, as well as the ticket price. The variable cost changes based on the number of passengers that are showing up for the flight, but the ticket revenue remains the same. And we want to calculate the overbooking cost using an if statement. So where can we begin? The first thing to do is understand what an if statement is asking of you. We want to create a logical test, and if that logical test is true, we'll assign a value to it. And if that logical test is false, we'll assign a separate value for that. So our if statement centers around whether or not we will have to bump passengers off of our flight. You'll notice that with 240 people showing up, we have 10 available seats, and we wouldn't have to bump anyone off the flight in column B. But in column H, we have 20 more passengers showing up for the flight than we have seats. And so we'll expect that this overbooking cost would be greater than 0. So let's start typing in the if statement. Using a logical test, we need to have a greater than, a less than, an equal sign, or a greater than or equal to less sign, or a less than or equal to sign. So in this instance, if the number of passengers showing up, cell B3, is greater than the number of seats available on the plane, we will need to calculate the overbooking cost. Now, to find the difference, or the number of seats that we have overbooked, we will use cell B3 minus B2 and multiply this by the overbooking fee, B5. You'll notice that I encapsulated B3 and B2 in parentheses. When you're using Excel, you want to follow the rules of PEMDAS, making sure that you encapsulate multiplication and division in parentheses if necessary. You'll notice that this is the value if our logical statement is true. If our logical statement is false and we have not oversold the flight, the value would be $0. So we'll enter 0 in there. We'll close our parentheses to encapsulate it in the if statement and hit enter. And since Frank has set the formatting to accounting, you'll notice that you get a dash that represents that you have no overbooking cost. We'll take this formula and drag it over by taking the lower right-hand corner of the box and dragging across. You'll notice that in columns E through H, our overbooking costs are greater than 0. This makes sense because we have more passengers showing up than we have seats available. Alternatively, we could have copied this cell by hitting Control-C and holding down the Shift button and using our right arrow key on our keyboard to highlight across. Then hit Control-Alt-V. We want to paste as a formula because that is the only thing that we want to copy over. If you copy over all, you'll copy over the formatting as well. And in this example, it doesn't matter, but in other examples, copying the format can distort the image on your screen by copying, formatting, the coloring of the cell or the outlining of the cell that you don't want. So we'll copy over just the formulas, and we can hit enter, and you'll notice that we get the same values. That is if statements for tab 1. We'll continue on to tab 2. In this tab, our company is producing a new drug, and we expect that in year 1, our sales are going to be 100,000 units. And we expect that for 3 years, these sales will grow, so all the way through year 4. And we expect that after that, for the next 7 years, our sales will decline. When our sales are growing, the rate will be 15%. And when our sales are declining, our decrease rate will be 10%. And we need to create a formula that can be copied down from cells B7 to B16. Now you'll notice that we have all of our information up at the top of our spreadsheet. The value of doing this allows us to change these cells at any time if we expect these numbers to change. but it also requires us to reference the cells using an absolute reference, and we'll learn how to do that right now. So in year one, we already know that our sales are 100,000. So we will reference by hitting equals A2 this cell. What this allows us to do is if we expect our year one sales to change, we can change those sales in cell A2, and it will automatically update in cell B6. I'll change this back to 100,000. Now we need to create an if statement that will be satisfactory for cells B7 through B16. So we need to create a logical statement. Now, if our year is less than or equal to the value of B2 plus 1, we expect our sales to grow. Why is this B2 plus 1? Well, we know that growth years is a value of 3, which means that after year 1, we'll be growing for 3 years, which should take us to year 4. So in order to get to year 4, we need to add a plus 1. We never want this B2 value to change, so we are going to absolute reference it by hitting F4, or if you have a newer laptop, you'll have to hit your function key at the lower left-hand corner of your keyboard, and then F4, and you'll notice that that adds 2 dollar signs. Each dollar sign keeps the cells constant. So when we drag this formula down into cells B8 and beyond, B2 will always show up. On the other hand, we want A7 to change to the value of A8, A9, A10, and so forth. So we're not going to absolute reference that. The only absolute reference that we might consider doing is adding a dollar sign in front of the A. What this will do is ensure that this formula never leaves column A, because you'll notice that we're dragging it down column A. If you want to get a dollar sign in front of just an A or the 7, you can either type in the dollar sign or continue to hit F4, and you'll notice that Excel changes where the dollar sign is placed for you. If we wanted to keep our formula pulling from a single row, we would put the dollar sign in front of the number of the cell. So we have our logical statement. If this value is true and our year is less than or equal to year 4, then we want to grow the year prior, in this instance B6, by a rate of 15%. Now, as we drag this formula down, we would like the year prior to change with it. So we're not going to absolute reference B6 other than adding a dollar sign in front of the B to keep it in the B column. But we also want the growth rate to stay the same. And so we're going to absolute reference both the D and the 2 to always pull from cell D2. What this will give us is a growth rate of 1.15 or 15% above the year prior, when the year is less than or equal to 4, rather. If the year is greater than 4 and we are in the 7 years of decline, then we will have cell the year prior, in this instance B6, we'll absolute reference the B. We'll multiply that by 1 minus the decrease rate. We'll absolute reference E2. This will give us a value of, or rather 90%. So our sales rate will go down if our year is greater than year 4. You can close the parentheses and hit enter, and you'll notice that our sales rate goes up by 15% in year 2. We'll copy this value, hit Shift and the down arrow key to copy down, Control-Alt-V, we'll paste the formulas, and you'll notice that up until year 4, we are increasing, and after that, we decrease. If we click on any of these formulas, you'll notice that A13 moved down because we did not absolute reference the number 13. but B2, D2, and E2 all stayed the same. That's the value of absolute referencing. If we were to have entered in this the number 4, the same value would come out. You'll notice it remains the same, 99,785. The issue with this is if we go back and decide that our growth year will be 5 instead, now this value isn't going to be correct because the growth years is stuck on 4. So we want to make sure that we're absolute referencing. That makes our workbook much more flexible. So we can change it to 4 years of growth, we can change it to 8 years of growth, and all of our data will automatically update. You'll notice that the decline years is written as a formula so that all we have to do is change the growth years. And we can likewise change the growth rate. Let's say that we expect to grow at 30%. And you'll notice that all of our values change automatically. We want to get used to absolute referencing because this will make our workbook much more flexible and it will make your lives significantly easier as we get to more challenging problems. Once again, in order to absolute reference, all you need to do is hit F4. If you have a newer laptop, you need to hit the function key, Fn, and then F4. And remember that you can either absolute reference the column or the row or both. Now let's look at what happens when we absolute reference just the column. In this case, I will absolute reference cell B2 and just the column, so B. I drag this value across, it remains at 3 because it's keeping the column the same. So we're staying in B, but when I drag down, you'll notice that the rows can change. So we're pulling from units sold and then all the way down this yellow column in this instance. Likewise, if we were to reference B2 and just absolute reference the second row, we'll never leave that second row no matter how many times we drop down. But if we went across, we'll go in different columns, always staying in row 2. And if we absolute reference both the column and the row, no matter how many times we copy this cell, we'll always get the value of 3. So that is homework tab 2. Titled drug. Next, we will move on to the model, the build a model titled candy. You'll notice that in this instance, our workbook is completely blank, so we have to build this from the ground up. Now, after reading through the situation, we know that we are trying to make 2 types of candy and that we have 10,000 ounces of sugar, 2,000 ounces of nuts, and 3,000 ounces of chocolate at our disposal. And we have a constraint that we must have at least 20% nuts in our Easy Out candy and at least 10% nuts in our Slugger candy and 10% chocolate in our Slugger candy. And once we've made our product, we can sell this for 50 cents for Easy Out and 40 cents for Slugger. And what we are trying to determine is the maximum revenue that we can make from our candy sales. So what I want to do is get all of our information on our Excel document. So let's write how many supplies or ingredients we have at our disposal. For sugar, we have 10,000 ounces. For nuts, we have 2,000 ounces. And for chocolate, we have 3,000 ounces. And the mixture requirements say that for Easy Out, you must have at least 20% of the product be nuts. And for Slugger, you must have 10% as nuts and 10% as chocolate. When you type a percent symbol after your number, it changes to a percentage, which would be the equivalent of a decimal 0.1. It's a nice feature on Excel. And the revenue that we earn from Easy Out is 50 cents, and the revenue from Slugger is 40 cents. Now, right now, I am just typing out all the values that we have, but you will want to go back and format these to look nice. You can add borders by using the border function. And I would also recommend highlighting your cells using a light color, especially for your input cells and potentially as well for your output cell. The input cells are the cells in Excel where you will physically enter a value. Everything else in your model should be able to stay consistent. So now that we have all the information outlined, let's start designing our model. So for our inputs, we need to decide how many ounces of sugar, nuts, and chocolate we want to have in our candy. This takes these cells as our input, so we'll go ahead and highlight these. I'm also going to turn on grid lines. You can do that in the View tab, and this makes it easier to design your workbook while you're still working in it. For now, I will place a filler number of 1 in all of the cells, and this will come in handy later on. I'll edit this to find our final answer. And I want to sum up the total ounces of both Easy Out and Slugger. And I can do this by using the sum function, and then selecting the cell, holding the shift key down, and hitting the up arrow. You'll notice that when we sum consecutive cells, it shows up as a colon. So you could have typed F2 colon F4. We'll close the parentheses, and you'll notice that this sums up. We'll copy this value over. Now you'll notice that under Slugger, we're summing the values of those ounces. Now, because we have a finite amount of sugar, nuts, and chocolate, I also want to sum the total of all three. So we will sum the amount of sugar, nuts, and chocolate. And we'll title this Total Ingredients. Now the question asks for the amount of revenue that we are earning. We'll multiply the total ounces of Easy Out by revenue that we earn from each Easy Out ounce. And we'll do the same thing for Slugger, multiplying the total number of ounces of Slugger that we have made by the total revenue, 40 cents. And we're going to reference these cells because if we decided that we could actually earn 50 or 60 cents for Slugger, then all we have to do is change the value of our revenue in cell B15, and your entire model will update. We want to find the total revenue, so we'll sum our two individual revenue amounts. And then we only have to add one last section. Remember that we are required to have a certain percentage of both nuts and chocolate. I don't have any sugar amount, but I'll add it in case we change our mind later on. In order to get the percentage of nuts to the entire ounces, we'll simply divide the amount of nuts by the total ounces in Easy Out. We'll do the same for Slugger. And then we also have to do this for chocolate as well. Great. So now we are ready to start running some modeling. Now, if at any point throughout creating your workbook, you want to check your formulas, if you hit the Control tilde hit Control and then hit the tilde key, which is the little squiggly in the upper left-hand corner of your keyboard, you'll notice that all of your cells have changed to the formulas that you've typed in. This is a great way to check that you have typed in everything accurately. And likewise, once you're done, you can hit Control tilde again, and it will return to the numeric value. Now we are going to use something called Solver, which you will learn more about later on in this course. If you don't already have Solver downloaded on your Excel, it's a free add-in, and in order to get this on your Excel, you need to hit File, Options, go to the add-ins on the left-hand tab, go down to the bottom of the box and hit Go, and you'll notice Solver add-in is an option. Make sure it's checked and hit OK. Once again, that's File, Options, Add-ins, Go, Solver add-in, and hit OK. What Solver is going to do for us is test a whole bunch of different numbers in our input boxes to see what gives us the highest amount of revenue. This saves us a lot of time from having to manually try and test all sorts of different numbers. Now the Solver add-in can be found in the Data tab. Once you've downloaded it, it'll automatically show up under the Analyze box. So we'll go ahead and hit Solver, and a pop-up box will appear. Now there's a couple things we want to enter in order to make sure that this runs correctly. The first is our objective. So what we're trying to do in this example is maximize our revenue. So we want to hit our max revenue box, which in my example is in cell G7, and you'll notice that it absolute references so that it never changes. And we want to maximize our value by changing the variable cells. So go ahead and click in this box, and we're going to select our highlighted cells, our input. So what Solver will do is edit all of these numbers until it finds the most optimum number. And remember that we have a couple of constraints. So in order to add some constraints, we'll hit Add. And we want our total ingredients to be less than or equal to the total ingredients that we have. So we summed up our ingredients in the H column, and we told how many ingredients we have in the B column. So because they are all next to each other, we can just, once again, drop, select H2, and highlight all of these. Make sure it's set to less than or equal to, because we can't go over the ingredients that we have. And we'll set the constraint once again to the values in B2 through B4, ensuring that we never exceed 10,000 ounces of sugar, 2,000 ounces of nuts, or 3,000 ounces of chocolate. We also have to add these percentage constraints. Remember that our nuts in easy out must be greater than or equal to 20%, and we'll add this constraint. Our nuts in Slugger must be greater than or equal to 10%. And the chocolate in Slugger must be greater than or equal to the chocolate constraint that we have already laid out. We'll hit OK, and we notice that we have 4 different constraints. Now, in order for this to run accurately, we need values in our input cells, which is why I added a 1 into each of the cells earlier. Otherwise, what it would do is cause a divide by 0 error. You'll see the divide by 0 error here. So we want to add 1. If you X out of the Solver parameters box, all of your information will stay saved, which is very nice. We want to make sure that the selecting method is set to GRG nonlinear, and we'll hit solve. This pop-up box will show up, and if everything ran correctly, it'll say Solver found a solution, and all the constraints and optimality conditions are satisfied. Now it looks a little messy, But if you reduce the number of decimals, you'll notice that all of our values come out very cleanly. And we have gotten a maximum revenue of $6,500. And just to be very clear, we'll change these to percentages. And you'll notice that Easy Out has met the constraint of 20%, and Slugger has met and exceeded the constraints of 10 and 10%. Now, when you're formatting these cells, you'll want to add borders. And you'll also want to edit certain cells to make sure that, for instance, revenue shows up with dollar signs. We don't need the additional decimal points for cents. It's just not necessary. We're dealing with fairly large numbers, and we really don't care about cents. They'll end up being just rounding errors. We want to make sure that our percentages are set to percent rather than decimals. There's a lot more that you can do to make this particular page look really good, but I will leave that up to all of you to figure out. Just make sure that it looks nice and professional. Those are the three questions that we went over in the review session. And then I also went through the bid tab just briefly to really explain what you need to do here. So in the bid tab, we are a construction company, and we are attempting to determine how much money we would make if we bid on certain projects. You'll notice that in the yellow row, we need to identify if we have won or lost the bid. And you can do this using an if statement or a logic statement that would produce the value true or false. If you don't know how to use the true or false statements, go ahead and design your if statements to make sure that you are testing to see whether or not you're winning the bid. You also need to write an assumption out. The reason that you need to create an assumption is that you need to tell me when you expect to win a bid. So if you expect that if you are the lowest bidder, you would automatically win, tell me that. Also tell me what happens if you and another competitor both have the lowest bid. Would you always win, always lose, or sometimes win? And how will that affect your equation? You need to make sure that your equations and your formulas match the assumptions that you're making. So for instance, if we were looking at cell B, or column B rather, we can do an if statement that requires our bid be less than or equal to the minimum of the other four competing bids. If that value is true, we can write the word win. And if that's false, we can write the word lose. Make sure that when you're writing words, you're putting them in quotations. And you'll notice that in column B, we lose. Then you need to figure out the profit based on if you lose or win. For each bid, you have to pay $400 in order to make the bid, which means that if you're losing, your profit will be negative. You will be having a loss. Make sure that you include that $400 in all of your scenarios. Don't forget that. And those are my hints for the tab bid. If you have any questions with the homework, please email me. Once again, my email is on your syllabus and can be found on UB Learns. Your homework is due Sunday night, I believe. Check that in your syllabus. And hopefully we will get the recordings working for next Tuesday's course. Once again, we go on at 8:10 p.m. every Tuesday night until 9:45 p.m. I'd love to see you all there. We went through tabs tickets, drugs, and candy. And we briefly talked about bid today. If you ever have questions, feel free to email me. I prefer that you come to the review sessions with questions and ask me beforehand. You can always ask me to go over certain tabs if you shoot me an email before the class begins. I hope you found this helpful. And once again, reach out to me if you have any questions. Thank you very much.